So as I told you, there's multiple rules to exponents. You learned about the zeroth rule. You learned about exponents to the first power. You learned about negative exponents, multiplying like bases, the quotient rule. The last one is power to power. So when you have a power raised to a power, you multiply the exponents. So say you had a to the fourth. You know that would be a multiplied 4 times. If you had a to the second to the fourth, that would be a to the second multiplied 4 times. You know from last week, when you're multiplying like bases, you add the exponents. 2 plus 2 plus 2 plus 2 is a to the 8th. And if you had just multiplied your exponents, you would have gotten the same thing. So the general rule is a to the m to the nth is the same thing as a to the m times n. So we are going to start simple and then make life a little more difficult. So I like to think of parentheses. I like to bring it to distributed property because whenever you saw distributed property back in the first chapter, you knew to multiply. Now, is this distributed property exactly? No, but it's a kind of helpful way to help you remember. So an arrow has to come from the outside exponent inside the parentheses to every exponent there is. So you keep your base, multiply your exponents. 5 times 6 is 30. So the answer to this one is a to the 30th. Take your outside exponent, draw an arrow to every exponent inside the parentheses. 6 times 0 is 0, but we know anything to the 0th power is actually 1. So our answer is 1. This is the trick that you have to worry about that you don't want to screw up. And this guy, how many arrows are coming from the 8? Hopefully you said 1. Keep your base, multiply your exponents, and you get x to the 56th. So now sometimes you obviously have more than one number in the parentheses. So again, just like distributed property, when it had to go to every term in the parenthesis, this is also going to have to go to every exponent. So a to the second becomes a to the 2 times 6, which is a to the 12th. B to the 5th, 5 times 6 is 30. You have 2 different bases, so you're done. Now this one, how many arrows are coming off the 5? 2, because you have 2 exponents inside the parenthesis. So x to the second becomes x to the 10th. Y to the third becomes y to the 15th. 2 different bases, so you're done. How many arrows? 2. X to the 0 becomes x to the 0 times 5, which is x to the 0. Y to the second becomes y to the 2 times 5, which is y to the 10th. We know, however, that anything times 0 is 1. So your final answer is just going to be y to the 10th because we know there's an invisible 1 there. This one, how many arrows are coming off the 2? 3, because you have 3 exponents on the inside. X to the 5th becomes x to the 10th. Y to the 6th becomes y to the 12th, and z to the 10th becomes z to the 20th. So now sometimes you are going to have a constant in your parentheses. This is where you're going to screw up if you're going to screw up. Whenever you have a constant, you still have an invisible 1 on the constant. So every constant needs to have a 1. So instead of only 3 arrows coming out from the 3, there's actually going to be 4. So 6 to the first becomes 6 to the 1 times 3, which is 3. A to the second becomes a to the 6th. B to the 5th becomes b to the 15th. And c to the 0, 0 times 3 is 0. We know anything to the 0th power is 1, so that goes away. Over here, 6 to the 3rd we know is not 6 times 3. It's 6 times 6 times 6, which is 216. And then you just drop everything else down. So you got to remember your constants get a 1. So now, a little harder. All right, looking at this first one, how many 1s do we have to add? 2 of them, because you need 1 on the b and 1 on the constant. So how many arrows are now coming off the 6? 4. And remember, what are we doing to our exponents? We're multiplying. 1 times 6 is 6. A to the 3rd times 6. B to the 1st becomes b to the 6th, and c to the 10th. 10 times 6 is 60. Now we know what 2 to the 6th is. It's 2 times 2 times 2 times 2 times 2 times 2, which I believe is 64. It is. So my final answer is going to be 64, and then drop all that stuff down because we don't have any zeros to take care of. So now this one, how many 1s do I have to add? Yep, and how many arrows are coming off my 10? Hopefully you said 6. Again, we're multiplying our exponents because it's power to a power. 9 to the 1st becomes 9 to the 10th. X to the 5th becomes x to the 50th. Y to the 2nd becomes y to the 20th. Z to the 30th. A to the 10th. B to the 0 times 10 is 0. We know anything to the 0th power is 1, so that goes away. Rather than rewriting it, I'm just going to erase it. So this is your final answer. All right, one last problem. So say you had this. Ooh, that is not a pretty X. So back when we were doing equations, we always said, where does your I go? Your I goes to parentheses. It's the same thing when you're working with exponents. So looking at this whole shebang, your I should automatically go here. This 2 only goes to what's inside the parentheses it's attached to. So your arrows don't go to the right, it only goes to the parentheses it's attached to. And again, when you have a power to a power, what are we doing to our exponents? We're multiplying. So 2 times 2 is 4. 3 times 2 is 6. And I'm going to drop down this guy over here. So now you don't have parentheses anymore. You have a dot. That tells you you're multiplying like bases. So what's going to happen now is you're going to use your rule from last week. You know, when you have multiplications, wow. When you have multiplication and it's the same base, you keep your base and you add your exponents. So 4 plus 2 is 6. Keep your base, add your exponents, which are 11. which goes to 11. So this is your answer. What we're going to work on tomorrow is recognizing the difference between power to power and multiplying like bases.